Hello, everyone. My name is Derek Cameron. I work on the Oracle Code Innovate team. We work with customers to build solutions in a rapid 1-week time frame. This is all free to the customer. Give us a call if you're interested. Today, I'd like to talk about how you can use OAC federated queries to help address enterprise planning and budgeting issues. This is a follow-up presentation to one I gave back in January, where I talked about building visualizations on EPBCS. The customer was having performance challenges when they were accessing very large cubes with large dimensions, and the performance was slow when accessing through OAC. So this is a way to get around that problem, and federated queries, in fact, can be used for a lot of different things. The previous demonstration or recording was this one here, using OAC to build visualizations on data in EPBCS, and there's the link there. I'll provide this link in the next recording, and the one that I'm doing right now. I'll provide the link back to the old one. Take a look at that because they're going to be accessing very similar information. So let's get started. So what's the problem and how does OAC support federated queries? I'll cover that a little bit. It'll talk a little bit about the cube design, sparse and dense, but the bottom line is when you have very large cubes and you add dimensions, things like thousands of projects on top of your standard financial data, or in this case, the customer had added a dimension for employees and there was thousands and thousands of them. Of course, the size of the cube really explodes. And then when you're accessing it through OAC, it can be slow. So we'll take a look at the data, the cube data that's in EPBCS, and then I'll show you the relational project detail that's related to that, but it's held separately in a relational table. We'll create a very simple BI model on the relational data in the RPD. The EPBCS cube data is already modeled. That was from the previous presentation. And then lastly, I'll show you how to build a visualization that combines the summary cube data and the relational detail very simply and transparently. And you'll notice that the performance is extremely fast. This, of course, assumes that your databases are somewhat co-located, if not in the same subnet, but at least in the same data center. If your customers have got data in different other databases like Snowflake or other locations, of course, that would mean bringing data across the internet. So this does mean that you do need to have some kind of an idea of co-locating the data to some extent in the same data center. So let's get started. So let's start by taking a look at the cube data. I've logged into my EPBCS instance here. I go to application, I go to overview, and let's take a look at the cubes. The cubes are here. I covered this in the last presentation. This is just a bit of a review. And the cube that we focus on is this OAPFS, the financial cube here. And I want to just point out the dimensions. The dimension, you can see that for the OEPFS cube, that the account dimension has 600 members, the period 28, plan 74, and so forth. Now, the intersection of all these dimensions is the Cartesian product of each of these. So it'd be 627 times 28 times 75, etc. It's going to be tens of thousands, hundreds of thousands of cells. But customers have typically much larger cubes than this. They'll have hundreds of products, perhaps, many markets, different scenarios, different years. And so these cubes are going to be a lot larger than this. And then when you consider that they might want to add detail, much more detail, such as in our case, the customer was interested in adding employee and then adding projects, and there's hundreds and thousands of employees and projects, and next thing you know, this cube becomes very large, and accessing it through OAC can be slow. So if you look at where we might store the detail, let's take a look at that. If we go to here, we've got project detail in a relational table, and that's in OAPFS ops table. There is not that many rows here, but 2,800 rows with costs for Q1 through Q4 across 13 projects and across all these other dimensions here. An Oracle database can crunch through not 2,800, but 28,000 or even 20 million rows in seconds. So it really, this size of this doesn't really matter that much in terms of the performance. So what we really want to do is hook up the cube data and be able to transparently drill down through the dimensions and then out to the detail and make it look to the end user like it's really all just one model, and the end user can just not be concerned about where the data is coming from. It could come from multiple databases in the same model. And this is Oracle support for Federation. As I said, it's been around for many years. I think it's an underappreciated feature. Like a lot of the classic features, the focus more recently has been on machine learning and exotic data visualizations and data insights. And I think that's all great, but let's not forget some of the legacy features that are still critically important to our large enterprise customers, and in particular, the finance customers. So let's take a look at that. So we've got the project name, the project ID, the project cost here. This is the value that's being stored in the cube right now. You can see it repeats because each project has got multiple, or each account has got multiple projects. The total is this, the detail is this. So this is how I'm going to show you what that looks like. So I want to point out a very good documentation on the federated feature here, federating Essbase and relational data. Essbase is the underlying database for enterprise planning and budgeting. This article here goes through how you can add this, add the federated data models into the RPD, the classic RPD. And I actually had the plan that I would go through and follow these instructions and follow these steps. In my previous recording, I did have some federation there, but it was what we call horizontal federation. That's this here. I wanted to do vertical, which means I'm going to drill to additional detail rather than having different metrics at the same level. The one thing that I ran into almost immediately was the fact that all of this presumes level-based hierarchies, and we don't have that in EPBCS. We actually have parent-child hierarchies, so I would have to convert this into level-based, and I do cover that, but the level-based hierarchies I did find were slower accessing it. So while all this still applies and could be done, I am going to look at using the data sets and data visualization to do something very similar, and that is to combine these two data sources into one and then allow you to create DVs on top of that. So let's take a look at the RPD now. We go into the model administration tool. It's a Windows only tool. Again, I covered this in the last presentation. Let's expand it. We'll go File, Open, Offline. This is the RPD that we're using. So our data model, we're going to use the one that we've been working with in the past presentation. It's OAPFS. And what I'm going to do is add the data source, the project data, which is the lower level of detail that you saw in SQL Developer there. And that's this table here. Recall it was 2,808 rows. Again, I won't go into all the features of the admin tool. This is just focusing on the federated use case that we'll be covering today. So I bring in this simply by going into import metadata. I select the table, and this is it here. I drag it over to the other side here onto the modeling layer. I do need a dimension and a fact. The dimension and fact are tied to the primary key, which is the identifier here. And then the fact data that we're going to be integrating is the project cost, and the dimension members are going to be joined at the leaf level to the cube data. So the account name, currency name, identity name, market name, etc. All of that's going to be joined in the data set in DV, not here. Again, the recording or the documentation which shows how to model it in The RPD, that could be done here. Today, I'm not going to cover that. I'm going to cover joining the data sets in data visualization based on the fact that we're dealing with level-based hierarchies. And also, I just found it easier than updating a model in the RPD modeling layer here. So we'll be joining on the account name, the currency name, the entity name, etc. So let's take a look at that. So once we save the RPD, we do need to upload it. And we do that by going into snapshots. Let's go back here to show you the path for that. You go into OAC, you end up on the home page here. We go down to console, and under console, you'll see snapshots. And under snapshots, there's a menu up here. Go here and replace data model. Proceed without virus scanner. Select the model here. That's the one we've been working with. Give it the password that you've got for the RPD, and I won't do that here. And then you simply do a replace, and it takes a couple of minutes. Even after it says it's finished it here, the model does take a couple of minutes, 2 or 3 minutes, to become visible in the OAC console. Now let's take a look and see what this looks like in data visualization. I'm going to open a workbook that I created to showcase this feature. This is the notebook workbook here. And so what you'll notice is we've got 2 subject areas, 2 local subject areas, the original OEPFS. This is the enterprise planning and budgeting data source, and this is the relational data source. And I brought them together. If you go into data here, you notice they're joined. Let's take a look at the joins. It's at the leaf level, account name to account name, currency name to currency name, etc. So for all the dimensions, I've created a join key on this. And we'll look at how we can bypass that by setting the data joins up in a data set. So we don't need to do this every single time. So if we go into visualization, the other thing I'll mention is that, as I covered in the last presentation, you do need to set all the filters. I've become a big fan of the expression filter. I've got this in a notepad. It's just a lot easier than going one by one by one. And it's true, you don't have a drop-down list, but you have to know where the data is anyway. So all I do is cut and paste this into an expression filter, and I've got them all right here. So that's something to point out. And now let's take a look at the data. The value data here is coming from the cube. The project cost at the same level, Q1 for account, OFS other revenue. This is coming from the relational side. This one down here is actually a lower level of detail. This here is a level below that which is stored in the SBase or the enterprise planning budgeting cube. So if I click on, if I want to know what the 122,000 for product revenue is, I select that, and the brushing automatically does a filter, and there it is there, 122,654. I can just click around here. So you've got the summary information here, and you've got the detailed information down here. The really nice thing about the BI server, it's very aggregate aware at the different levels. So if I go into this visualization here, and I go into here, now their data sets joined, let's add this measure here. And you'll notice that it knows that this is a higher level than this, so it doesn't add it up and end up with wrong numbers. I didn't do anything in the model to set this up. I simply brought in the cube, dragged it to the business modeling layer, and then into the presentation layer. That's all covered in the previous recording. But the important point is the fiddly process of paying attention to the levels and setting them. It's all done automatically, pulls that from the cube for you. So this is really nice. You don't have to worry about incorrect numbers. It's all handled transparently for you. And you've got the drill down. I could add it to this one here as well, but I thought it would be kind of useful to have this separate here. There's federated costs here, but there's a lower level of detail here. And so you can imagine that this data source here could be millions of rows, and it wouldn't be contributing to the size of the cube here and dragging it down in terms of the performance. So I really like the way this operates. It's fast, it's slick, it's simple, very simple to set up. So let's take a look at what's happening under the covers. We'll do that by going to the query logs and see what the BI server is doing. Go back here, go back to the console, select the main menu, drop down to the console, and you will see session and query cache here. And so let's take a look at the queries themselves. The report generates these logs whenever it runs a query. Let's take a look at that. And what we're going to see is we'll see two queries. One, the query that goes back to the enterprise planning and budgeting cube. That's this here. You can see what it's doing. The expression filter, you'll see that in the where clause of the query. So it's issuing a query to the Essbase cube. And then if we scroll down to the bottom here, you'll notice that the source here is actually the relational database, the source OEPFS ops, and it's querying the relational detail, and the BI server combines both sources in the BI server to present to you the results all in one single visualization. Now, if we go back to data sources, you notice I set this up in the workbook itself, but I can very easily create a multi data set here. If I go into data, right click, open. And if we open that up, we've got the joins here. It's now a data set that's joined together. If I want to create a workbook off this, I can select this one. I'd apply the filters the same way I did the other one. There it is here. It's got both data sources in there. Then the user doesn't have to do all those joins every time they create a workbook. So I didn't create a workbook off this, but you could very easily do that. I hope you found this easy. You can imagine that with federated data sources, you could be drilling to transactional databases in different locations. You can transparently traverse those databases, either setting that up in the RPD or by using a data set in data visualization. Thank you.